Welcome back. Lesson 14, Primes and the Greatest Common Divisors. Introduction. An integer p greater than 1 is called prime if the only positive factors of p are 1 and p. A positive integer that is greater than 1 and is not prime is called composite. Let's give a list of the first 20 prime numbers. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71. Okay, if I have counted them correctly, these are the first 20 prime numbers. The rest of the numbers other than 1 are called composite. 1 is neither prime nor composite. Fundamental theorem of arithmetic. Every integer greater than 1 can be written uniquely as a prime or the product of two or more primes where the prime factors are written in order of non-decreasing size. Okay? So uniquely, if you want to write factorization into product of primes, you have to write the primes in a non-decreasing size. Well, why not just say increasing order? Let's write this out for 343. 343 is first 7 goes. 7 times 49. 49 in turn is 7 times 7. So 343 is 7 to the third power. Next, 500. 500 is 2 times 250. Notice I start with the smallest prime, which is a factor 2. Again 2 goes here. 2 times 125. In 125, 5 is a factor. In 25, 5 is a factor and you are done. 2 to the power 2. 5 to the power 3. Notice my primes are written in increasing order and the powers are written. Alright. 2048. 2048. 2 is a factor. 1024. 1024 is instead 2 times 512. 512 is 2 times 256. 256 is 2 times 128. So notice I have been writing the previous factors as they are. 128 is 2 times 64. 64 is 2 times 32. 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. Look at how many 2's there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 2 to the 11th power. Here is an important theorem. If n is a composite integer, then n has a prime divisor less than or equal to square root n. Okay, if it is a composite integer, that means it can be factored, okay, by something other than 1 and the number itself. The claim of the theorem is that n has a prime factor less than or equal to square root n. Suppose a and b are integers greater than square root n. I should have a square root n there. Okay, so suppose you have two integers a and b, both greater than square root n, then a times b and their factors. You see, a times b is n. If they are both greater than square root n, then a times b has to be greater than n, which is a contradiction. So, because there are factors, one of them has to be less than or equal to square root n. Well, let's say a is less equals square root n. If A is not prime, well, then we know that A has a prime factor because you can always factor your integers. There is a factor of A which has to be less than square root n. So you have found a prime factor of A, which is also a prime factor of n, and it is less than square root n. That has proved your theorem. Okay? Prove that 211 is a prime number. Well, if it is not a composite number, then you should be able to find a factor less than square root of 211. Let's look at it. Checking for 211. Well, 211 is between 196 and 225. So square root 211 is between 14 and 15. In other words, we need to check whether 211 has any prime factors less than 14. What are the prime factors less than 14? 2 until 11, okay? 2, 3, 5, 7, 11. 2 is not a factor, is not a divisor of 211 because this is odd, okay? 3 is not a divisor of 211 because you need to add the digits of 211. 2 plus 1 plus 1 is 5. This is a test for divisibility by 3. You add all the digits. If the sum is divisible by 3, the original number is divisible by 3. But in this case, 5 is not divisible by 3, so the original number is not divisible by 3. What about 5? Is 5 a divisor? No, you need to end in a 0 or 5. You don't. Is 7 a divisor? Well, you have to check it. 211, if I divide by 7, 7 times 30 is 210. One remainder. So 7 is not a divisor. Is 11 a divisor of 211? No. 11 times 19 is 209 and 2 more is 211. So you have a remainder here of 2. So 11 is also not a divisor, and that's all you need to check. You needed to check the primes less than 14. Okay, so you know that 211 is a prime number. Find the prime factorization of 231. Well, what about 231? Let's work with this. 231. 2 does not divide it. Okay? Because this is odd. Does 3 divide it? 2 plus 3 is 5 plus 1, 6. 6 is divisible by 3. So 3 is a divisor. So 231 is 3 times what? 77, right? 21 and 21, that's correct. Now we can factor 77. 3 times 7 times 11. All right, and that's it. That's your prime factorization of 231.